channel Knowledge of Friends. Subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your chemistry for class 11th, and that is your class 20th, which we had even though done and the 19th classes we had done in the last classes. This is your class 20, where in that we had done your unit 8, which is redox reaction. Unit 9 is your hydrogen, and before that part 1 till unit 7, which we had completed. Today we're gonna continue with unit 10, that is the S block elements, and where we had started up this and before, where we had done your physical properties. Now we'll discuss about the chemical properties here, but before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So here we go with the chemical properties. In terms of chemical properties, that alkaline earth metal are less reactive than the alkali metal. The reactivity of these elements increases on going down the group. And first chemical property in terms of it, we'll discuss about the reactivity towards air and water. Reactivity towards air and water. In terms of reactivity towards air and water here, where beryllium and magnesiums are the kinetically inert to oxygen and water because of the formations of an oxide film on their surfaces, and however the powdered beryllium burns brilliantly on ignition in air to give BeO and B3N2, where magnesium is more electropositive and burns with a dazzling brilliance in air to give MgO and Mg3N2, calcium, strontium and barium, that are readily attacked by air to form the oxide and nitride. They also react with water with increasing vigor even in cold to form hydroxide. Now we go for another one, which is reactivity towards the halogen. So in terms of reactivity towards halogens, all the alkaline earth metal combine with halogen at elevated temperatures, forming their halides, which will give metal plus X2, which will give you MX2. So where X is your fluorine, chlorine, bromine and iodine. Your X will be fluorine, chlorine, bromine and iodine. Where thermal decompositions of NH4 twice BeF4 is the best route for the preparation of BF2 and BeCl2 inconveniently made from the oxides, which is BeO plus Cl2 at 600 to 800 Kelvin will give BeCl2 plus 0. Now we have reactivity towards hydrogen. In terms of it, all the elements except beryllium combine with hydrogen upon heating to form their hydrides, MH2 BH2. However, that can be prepared by the reaction of BeCl2 with LiAlH4. So it will be 2BeCl2 plus LiAlH4 will give 2BeH2 plus LiCl plus AlCl3. Now we go for reactivity towards acid. So reactivity towards acids here, where the alkaline earth metal readily react with acid, liberating dihydrogen, which is your metal plus 2HCl will give MCl2 plus H2. Now for reducing nature, in reducing nature, like alkali metal here, the alkaline earth metal are strong reducing agent, and this is indicated by the large negative values of their reduction potential. However, their reducing power is less than those of their corresponding alkali metals. Beryllium has less negative value compared to the other alkaline earth metal. However, its reducing nature is due to the large hydration energy associated with the small size of Be2 plus ion and relatively large value of atomization enthalpy of the metal. Now we go for the solution in liquid ammonia. Solution in liquid ammonia, like alkali metal, the alkaline earth metal dissolves in liquid ammonia to give deep blue-black solution, forming ammoniated ions, and where it will give as plus X plus Y NH3 metal NH3X 2 plus 2 E NH3 minus. From this solution, the ammoniates MNH3 6 2 plus can be recovered. Now we go for another one, which is the uses here. So in terms of uses, the beryllium is used in the manufacture of alloy. Copper beryllium alloys are used in the preparations of high strength springs. Metallic beryllium is used for making windows and of X-ray tubes. Magnesium forms alloy with aluminium, zinc, manganese and tin. Magnesium aluminium alloy being light in mass and are used in aircraft constructions. Magnesium powder and ribbon is used in flash powders and bulbs, in sedentary bombs and signals. A suspensions of magnesium hydroxide in water called milk of magnesia is used in antacids in medicines, and magnesium carbonate is an ingredient of toothpaste, where calcium is used to the extractions of metal from oxide, which are difficult to reduce with carbon. Calcium and barium metal owing to their reactivity with oxygen and nitrogen at elevated temperatures, have often been used to remove air from vacuum tubes. Radium salts are used in radiotherapy, for example, in the treatment of cancer here. Now we go for another one, which is the general characteristics of the here, and that is the compounds of the alkaline earth metal. So here we go, general characteristics of compounds of the alkaline earth metal. In the same way here, the dipositive oxidation stage, which is M2 plus, is the predominant valence of group 2 element, and the alkaline earth metal form compound which are predominantly ionic but less ionic than the corresponding compound of alkali metal. So this is due to the increased nuclear charges and the smaller size that we have. And the oxides and the other compounds of beryllium and magnesium are more covalent than those formed by the heavier and the larger sized member, so that is Ca or strontium or beryllium. The general characteristics of some of the compounds of alkali earth metal are described here below. And on the same way, we'll discuss one of us, that is about the oxides and hydroxides. So we go for the same here. Oxides and hydroxides. So oxides and hydroxide is that alkaline earth metal that burn in oxygen and to form the monoxide and MO, which except for BeO have rock salt structure, and the BeO is essentially a covalent in nature, where the enthalpies of the formation of these oxides are quite high, and consequently they are very stable to heat. BeO is the amphoteric, while oxides of other elements are ionic in nature, and all these oxides except BeO are basic in nature and react with water to form the sparingly soluble hydroxide, which is we have here, that is Mo plus H2O will give MOH whole twice, where the solubility, the thermal stability, and the basic character of these hydroxides increases with increasing atomic number from MgOH2 to BaOH2. The alkaline earth metal hydroxides are, however, less basic and less stable than alkali metal hydroxide. Beryllium hydroxide is amphoteric in nature, as it reacts with acid and alkali both. So we have here Be, which twice plus 2OH minus give BeOH 4 2 minus. This is beryllium, that is your berylate ion. Now another we have BOH twice plus 2HCl plus 2H2O will give BeOH 4 Cl2. Now we talk about for the halides here, that is also the important one. So here we go. that is your halides. In terms of halides, except for beryllium halide, all other halides of alkaline earth metal are ionic in nature. Beryllium halides are essentially covalent and soluble in organic solvent. Beryllium chloride has a chain structure of the solid state as shown, so that we'll discuss here the beryllium structure. Ca B Cl that is we have B Cl. This is the structures of halides here. In the vapor phase, BeCl2 tends to form the chloro-bridge dimer, which dissociate into the linear monomer at high temperature of order of 1200 Kelvin, which is 1200 Kelvin, and the tendency to form halides, hydrates gradually decreases. For example, MgCl2.8H2O, CaCl2.6H2O, and SrCl2.6H2O, and BaCl2.2H2O down the group. And the dehydrations of hydrated chlorides, bromides, and iodide of Ca, Sr, and Ba that can be achieved on heating. However, the corresponding hydrated halides of Be and Mg on heating suffer hydrolysis, that the fluorides are relatively less soluble than the chloride owing to their high lattice energy. Now we talk about for the next one, which is about salts of oxo acid. The first is your carbonates, sulfates, and nitrates. So with the same here, in the vapor phase, BeCl2 that tends to form a chloro-bridge dimer, which dissociates into a linear monomer at high temperatures of the order of 1200 Kelvin, where the tendency to form halides, hydrates gradually decreases. For example, MgCl2.8H2O, CaCl2.6H2O, and SrCl2.6H2O, and BaCl2.2H2O down the group, and that the dehydrations of hydrated chloride, bromides, and iodides of Ca, Sr, and Ba that can be achieved on heating. And however, the corresponding hydrated halides of Be and Mg on heating that suffer hydrolysis. The fluorides are relatively less soluble than the chloride owing to their high lattice energies. Now we talk about for the another one, that is the third one, is your salts of oxo acids. So the first we have your oxides and hydroxides. The second we have your halides, and the third we have salts of oxo acids. In terms of salts of oxo acids here, where the alkaline earth metal also forms salts of oxo acids, and some of these were the first salts of oxo acid is your carbonates. So the first is your carbonate here. In carbonate, that the carbonate of alkaline earth metal are insoluble in water, and that can be precipitated by addition of a sodium or ammonium carbonate solution to a solution of a soluble salt of these metal. The solubility of the carbonates in water decreases as atomic number of the metal ion increases. All the carbonate decomposes on heating to give a carbon dioxide and the oxide, where beryllium carbonate is unstable and that can be kept only in the atmosphere of CO2, where the thermal stability increases with increasing the cationic size here. The second one we have is just sulfates. The second is we have sulfates. In terms of sulfates here, that the sulfates of the alkaline earth metal that are all white, solid and stable to heat. BeSO4 and MgSO4 are readily soluble in water, and the solubility decreases from CaSO4 to BaSO4, and the greater hydration enthalpy of Be2 plus and Mg2 plus ions overcome the lattice enthalpy factor, and therefore their sulfates are soluble in water. We'll talk about the next one, which is being the nitrates. So we have, that is your nitrates here. In terms of nitrates, that nitrates are made up of dissociation of carbonates in dilute nitric acid. Magnesium nitrate crystallizes with a 6 molecule of water, whereas the barium nitrate crystallizes as the anhydrous salt, and this again shows a decreasing tendency to form hydrates here with increasing size and decreasing hydrations enthalpy. All of them decomposes on heating to give the oxide like lithium nitrate, and on the same way it will be processed as metal NO3 whole twice will give 2MO plus 4NO2 plus O2, where M is Be, Mg, Ca, Sr and Ba that we have here. Now talking about the another that is your salts of oxo acids here. That is what we have to deal here in the detail about it. So these were the salts that we discussed. Now we go for the questions. That has been important one, that the questions we have: why does the solubility of alkaline earth metal hydroxide in water increases down the group here? So that is the another important question. So we go for it and we'll be finding it out the solution for the same. Let's go for it. The question is, why does the solubility of alkaline earth metal hydroxide in water increase down the group? So for that, among alkaline earth metal hydroxides, the anion being common and the cationic radius will influence the lattice enthalpy, and since lattice enthalpy decrease much more than the hydration enthalpy with increasing ionic size, the solubility increases as we go down the group. So I just write it on the solution for you all so that it will be helpful to you. Among alkaline earth metal hydroxide, the anion being common, the cationic radius will influence the lattice enthalpy. Since lattice enthalpy decreases, much more than the hydration, enthalpy with increasing ionic size, the solubility increases as we go down the group. Now we go for another question that has been important one. So for the same here, we go for another question that has been the important one, and the question is, why does the solubility of alkaline earth metal carbonates and sulfates in water decreases down the group? So that is the another important question. Why does the solubility of alkaline earth metal so we go for the next one, and that is the last question here. Alkaline earth metal carbonates and sulfates in water decreases down the group. So for that, the size of anion being much larger compared to the cation, and the lattice enthalpy will remain almost constant with the particular group. Since the hydration enthalpy decreases down the group, and solubility will increase as found the alkaline earth metal carbonates and sulfates. So here we go. The size of anion being much larger compared to cations, the lattice enthalpy will remain almost constant within a particular group. Since the hydration enthalpies decreases, down the group, solubility will decrease as found for alkaline earth metal carbonates and sulfates. What we have now, we're gonna end up with here only, and that will discuss the rest of the question in the next coming class, which will be your 20th class of the session. So that 20th we had done, even though, so we'll discuss the 21st class of the session. So here we're gonna end up with thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Please like, share and subscribe so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Other than this chemistry, we had done your quantitative aptitude we are dealing, which is arithmetical ability. We are even done your reasoning, which is your bubble reasoning and the non-bubble reasoning in terms of chemistry. We had done your part 1, where we had done your unit 1, which is your the some basic concepts of chemistry. Unit 2 is your structures of atom. Unit 3 is classifications of element and periodicity in properties. Unit 4 is chemical bonding and molecular structure. Unit 5 is the states of matter. Unit 6 is thermodynamics. Unit 7 is your equilibrium. Unit 8 is redox reaction, which we had done. Unit 9 is your hydrogen, which we had done. Unit 10 is the S block element, which we are dealing. After that we will do unit 11, that is the P block element. Unit 12 organic chemistry, which is some basic principles and techniques. Unit 13 is your hydrocarbon. Unit 14 is environmental chemistry. So after that we'll complete that chemistry. We are dealing with the physics as well, and that is the physics part 1, which we had started off. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Thank you.